and he can introduce the speakers. Thank you.
Thanks very much, Carl. Hi, I'm Sam. I'm from Australia, which is why I sound funny. But I'm also a really funny guy. Come and chat to me during the break. So I've got 3 talks, as Carl just mentioned. So speakers, you'll each have 20 minutes to talk, and then 5 minutes for question and answer afterwards. I will do that at you at probably at about 20 minutes, but at 18 minutes, I'll signal that you have 2 minutes left. 25 minutes, I'll pick you up and physically remove you from the room. So if I could please ask Tim Peto to come up and talk with that threat hanging over his head.
Hello. Can I tell whether this is being picked up, the microphone? It is. Right, okay. I'll give you go through our little story about how this all started. I'm a physician in Oxford with an interest in epidemiology, and we got involved in looking at the data coming out of Portland and organizing and thinking about how that ought to be done. Now, just to remind oneself, is that why do we test patients or individuals for COVID? There are different reasons. And I think we have to be really clear about this. You can do it because of they come in with symptoms. Is it COVID? Did you have COVID last week? Are you going to get COVID? But I think what we're talking about is testing for infectiousness. It's not quite the same. And we want to be really clear what it is we're trying to do. That was what we had in mind. Now, going back 2 years, or whenever it was, we were having views about why look at lockdown, quarantine, why we were doing that. Well, to prevent transmission, there were universal precautions, we understand that. And then you have the idea of locking up people who are particularly at high risk of being infectious. And these numbers are just guesstimates, which I did 18 months ago. So if you do a normal lockdown by region, if the whole of England gets locked down, you're probably locking down 1,000 people days to prevent a transmission, roughly. If you then quarantine known positives, or contact known positives, it's probably about 70 days of quarantine to prevent a transmission. And then if you get an individual who's symptomatic and got your cough, fever, and breathlessness or whatever they had originally, is getting about 70. So these are very inefficient ways of a lot of quarantine days, which is why most of the population didn't like it, as well as politicians didn't like it. So now we use PCR tests. That's come in. That is now, we're going back to the early days. And it's really interesting. PCR tests have been now thought of as the disease. And I think that's something which has come up. No one's really, when it came in, it wasn't evaluated, PCR, it was just done. And I think it's an interesting thing to look back. This isn't a PCR session, but I just want to remember that. And it's difficult. You've got to have laboratory trained staff, it's expensive, and that's one of the reasons why it's now being stood down. It's too expensive to continue in large numbers. The other thing to remember about PCR is you get, in terms of infectiousness, you get false positive rates. We know that. You go on being positive for weeks after you're infectious, RNA fragments. You also get false positive because of laboratory contaminations, and that happens with PCR and happens regularly, happened in the UK. And you also get, if you want to know whether you're not infectious today, PCR isn't very good because in the high transmission areas, you get the thing 2 days ago, and that's quite a long time. So really, you can't get a certificate of cleanliness from a PCR test. You might think you do, but you don't. Not in high transmission times. So I put down, if you're PCR positive, you've probably got 20 quarantine days. And if you've got symptoms and a PCR positive, it's probably quite good, and probably 5 quarantine days to prevent a transmission. That's quite effective. I mentioned the fact it misses infections, and what we want to test to release people from quarantine. And the question is, and that's been a debate, and people get very heated about this, do lateral tests do this? You know about lateral test, it's an old slide. The important thing is that it's very specific. And monoclonal antibodies are really good. So it's really good, specific and sensitive to detect antigen in the sample, which will react against that monoclonal. That works very well. The question is whether that's what you want. Now, what about viral infectiousness? Well, obviously, the more viruses, common sense tells you the more infectious you are. We don't know how many dose of virions you need. If you culture virus, we have no idea what the relationship between virus culture and infectiousness. We don't know whether different body compartments matter. It might be that the saliva is what matters, because if you haven't got virus in your saliva, then it possibly doesn't matter whether it's in the lung. I'm not saying I know that. I'm just asking that. And we just don't understand that bit problem. So when you do your little swab, it's not quite clear whether you're measuring the right thing. And now, how do we evaluate LFDs? Well, we do it by, we haven't got an antigen test, which is as a calibrant. So you normally test your kit against the antigen, but we don't. We use it indirectly by looking at RNA, which isn't what the lateral test does not measure RNA, it measures antigen. The other thing is we're doing quantitative RNA, which is the PCR tests are not really licensed to do. Really difficult, very inaccurate. CT values vary from lab to lab, and if you go, you can have a million-fold difference. I mean, it's just very, very difficult. But we do our best. And the other thing is, there's an assumption that there's a one-to-one correspondence between concentration of RNA and antigen, who knows? And of course, you probably all know that you can have dead virus, which is RNA inside, protein shell outside. You can have just the fragments I mentioned before, or you can have an empty shell thing where you've got antigen and no RNA in the middle. You've got to have both, and it's got to be alive to work. So what happened? Well, we're back now in May, June 2020. And Portland was sent by the Department of Health lots of kits. Just to be quite clear what happened, the Department of Health has sent millions of kits by different manufacturers, and they did due diligence about whether the kits were manufactured by known companies, and they could, could they do it in large numbers. And about 150 kits over the last 2 years have been sent to Portland. And they do some simple screening, check that they don't cross-react with other viruses. And the first thing you do is you go and get pure virus and culture and see what the sensitivity is, and as we did with the INOVA test. And you can see by the time you get to about 40, you get about 50% of the kits are positive. And we, at 100 is not too bad. It's expensive to do. And then having got ones that seem to work, we then had a bank of 200 samples, real samples from real people, put into freezer. We diluted it a bit to make the high viral loads. We made bigger volumes and made 1,000 negative samples to look for specificity. And this allowed us to compare different kits. The other thing to point out, which is part of the terrible problem we've got, is that you need to take a swab and put it into, for PCR, you put into 3 mils of virus transport medium. But when you take your kit and do it at home, you put it into about 200 microliters. So it's more than 10-fold more concentrated. So you've got to adjust for that. And I can tell you that adjustment isn't always done, and particularly wasn't done at the volunteer study at Imperial when they published it. You get results. I'm doing it, but the first lot, there's a number of kits, and we go and look at the viral load, and we see how many are positive. And we do about 900, 1,000 negatives for specificity, and you get results. And you don't have to look at it, but that's what we do. And the next stage after that is we do some field testing. And just remember, when you do field testing, they say that you're meant to be symptomatic when you go there, but 20% aren't when you ask them. Who knows why you go to have a test and trace? You know, you can make assumptions, but millions of people have gone, they go for different reasons. And we take 2 swabs, one swab for PCR, and one swab we do locally by putting in 200 microliters. And that gives you an idea of how it works. But we don't think about the variation between the swabs. And I can tell you, do 2 swabs, huge difference. I know it's a different techniques of swabbing. It's not clear whether it matters, and it's quite hard to get ideas. The sort of results you get is, which we published years ago now, is if you get to about 10,000 to 100,000 viral load, and TT is 25, 28 on our particular machine, that's about 90% are positive. And if it goes down to less than 10,000, you start failing. And that's the distribution of the viral loads you get in that particular population. Now, there's no single figure that summarizes this. And so what we did logistic regression to try to get some idea of consistency, and you get these logistic regression curves. So the red one here is innovative, the first one of the block, and you can see the shapes of the curve are different because the affinities are different, and you can possibly say, here's the sensitivity at 10,000, 60% in this case, at 100,000, about 90% in that case for Innovo. But this is complicated. So what's the relationship between viral load and infectiousness? So what we didn't know, I've mentioned it was awkward. So what we wanted to do is to get a direct test. So we went back to test and trace, as you know, do contact tracing, and you can get the contacts of people who are positive, and they turn up, and you can see which ones of the contacts actually got PCR positive disease. And we've got about 400,000 contact case pairs, and we did some stuff, and it was all rather nice, lots of data. Now, no allowance was made for third-party transmission, and so if you get someone who names a contact that gets locked up and tested possibly, they may have got, that contact might have got from a third party, but we don't know that. And you get this sort of result. These are the PCR results, and you can see low PCR means high viral load, and the chance, if you look at household contacts, about 15% were positive with high viral load, and it goes down as the viral load goes down. Is what you expect. And you can see that household contacts are more likely to happen than if you are at work or doing other stuff, contacts outside the house. The other thing which you can look at the age, and there's a difference in age, and it's quite interesting. You get some idea of this. Obviously, there's an error because we don't know that the donor was the donor. And I'm just going to pause on this one. So we had the 400,000 people, and there were 160,000 donors in test and trace who had a positive contact. And they had different viral loads. And this is the distribution in red of all those viral loads. As you can see, that's the percentage cumulatively. So about 50% of all the donors were above 1 million. So that's the first, that's the distribution of viral loads of people who went on to donate. And the black ones are the ones that were missed by the Pcr test. We were predicted to have been missed by the Innovo test, given the performance we had. And so overall, 85% of all the whole thing is red, and therefore we reckon that 85% of the potential transmissions of that 400,000 people would have been detected by that Pcr test. If they'd been locked up, the transmission wouldn't have happened. Now, what isn't clear, of course, is whether those ones missed by that Pcr test are actually causing disease, or whether they're actually not the donor. We've got some evidence, weak evidence, there's a lot of those things are not true, but in terms of our results, we assume all of these are donors. So we then apply this to different kits. An important thing, making this adjustment, boring adjustment. And this is the results of different kits. I've labeled some, and that's the sensitivity at 10,000. And what's interesting, and that's the proportion we predict of transmission would have averted had we used them on a test set of 18,000 successive test and trace people. And you can see we're getting about 85%. There's Innovo here. Orient does better. And there's FlowFlex. I've only put in names I'm allowed to put in. We're about nearly getting permission to publish all the names. And or you can do it another way, which is to look at all the tests we've done up to the 25th of May. I've put in some which are available, but there's quite a lot of noise. And actually, I don't really know what the real area on this is, but that gives you some idea. These down here, we sort of fail. But up here, we think these differences probably don't matter very much, and nothing's perfect, and it is quite hard to be certain how good it is, but that's what we've got. And at the moment, and actually I haven't shown you, most of the current tests are all doing much better. The manufacturers are getting better at it, so they're tending to go up here. And then, does it work in the real world? We did the school study, which I won't really go into because no time now, but we randomized 200 schools, and half were given normal quarantine. That's children who were in contact were quarantined as usual, and the other half, we did lateral flow tests every day and released them into the school if they were negative, and there wasn't much difference. So in that sense, we felt it was a reasonably safe thing to do, and the government took that on that study. So we reckon that if a lateral flow test is positive, even if you're asymptomatic, you probably only quarantine about 5 days, less than 5 days to prevent the transmission. Follow-up studies, it's getting better over time. It's a rather boring study, but there was a lot of fuss about healthcare workers and naive workers. In fact, the current naive patients doing it themselves are doing as well as the old healthcare workers did 2 years ago. So everybody's getting very good at it. There's not much difference between, we don't know about self-testing is good. What about different variants are all working fine? And I mentioned the large variation. The one thing which bothers me is discordance between that preferred test and PCR in middle range. And we've done some antigen test. So just looking at this a bit carefully. This is the RNA copies of a particular sample, that one there. And that one is how much antigen you measure quantitatively. And the red dots are the ones which are at lateral flow test positive, and the blue ones are the ones that are negative. So if you look at the mid-range here, you can see that the positive ones are the ones with higher antigen compared to the blue ones, which are negative. So they've all got the same RNA levels, and there's a discordance in the antigen with the RNA, and the antigen, lateral flow test is picking up the antigen. Now, that makes sense, but I don't know the biological significance of this. My bias, and I want to believe, is that antigen, you need antigen to be infectious, and therefore the lateral flow test is picking up the infectious ones, but I have no real evidence for that. That's just me being optimistic as a politician in me. So in their summary, I think they're good at detecting antigen. Probably they revert more than 85% of omnital transmission, what we say. We don't know about the discordance. And the other thing is saying, this is proved far more popular than we predicted. I never thought so many people would put things into their throats and noses every day. I thought they would never do it, and they have done.
Thank you very much for that, Tim. We've got time for 5 minutes of questions. I'm sure this is a lot of food for thought for everybody first thing in the morning. Anyone hands I will take? Yeah, I've got a question here and then I've got Carl.
Thank you. Can you say a bit more about ideas straight? The link between viral loads and infectiousness is something we worry about a lot. And obviously today we're going to think about viral load versus test positivity. But is viral load really the only sort of hidden thing that sort of links test positivity and infectiousness? Can you say more about that's the thing we need to talk about?
Okay, I think that all the infectiousness, you're going to have a number of virions going into you to infect you. What the inoculum is it 1, 10, 100, or 1,000, or 1,000,000? I don't know. And secondly, I don't know whether it matters where it goes. Nose, throat, I'm just not clear. And that makes a difference in your, and then there's a question about behavior of the donor and recipient, which is a separate thing about whether or not what you breathe out gets into the victim. I think it's live virions. The worry we've got is how do you measure live virions? Culture is really very poor. It's the right thing to do, but it's incredibly expensive and not very accurate. So I just don't know. I mean, what I think is you probably need to have both the RNA test and the antigen test together and see them as being orthogonal, not quite orthogonal, but sort of they are. If we were wiser, we would put them together and have it, so you've got as a surrogate for live variant. We aren't doing that. we're saying if they're discordant, which I might say PCR wins. That's the sort of conventional view.
Carl, is there anyone else with a question that came up? Yep, please.
I was wondering about the timing, the timing of the test and then the contacts trace afterwards. So, but are these household infections always presumably after the positive test, and then I guess the viral load might then go up?
Yeah, I mean, clearly this is a snapshot game. We do have from test and trace the time of onset of symptoms and the time of the contact, and we do have dates. And we did sensitivity analysis about whether it mattered. I think with day 2 to 7 after the people going positive, day 2 to 7 after the contact, we took. It wasn't a terribly critical decision, but we did that and that gave you the steepest curve. If you went further out, that the curve sort of went wrong. We also haven't done, I mean, but obviously this is, I mean, this is not a dynamic thing. The volunteer work gives you much lovely, nice news about dynamics, which is quite interesting.
I guess I'll finish thought. I'm sharing.
No, I was just thinking in terms of the potential infections caused by the lateral flow test. That's assuming it was done at the same time as the PCR.
Oh, in these tests and tracings, they were done at the same time. They were done exactly. We're not using one day apart things for this.
Thanks. So I also had a question about this relationship between viral load and transmissibility of contact tracing data. And I was just wondering about this problem with not knowing if there is a possible third-party infection between the case and named contacts who then went on to develop infection. Could you vary the periods of time or vary household sizes or to try and vary the probability of third-party infection?
What I did, limited success, was back when there was Delta and coming, Alpha and Delta, no, old and Alpha, there was S positive PCRs, and therefore we've got a discordance between donor and recipient. You could argue that it was a false positive. There are numbers of cases, and we also did some full sequencing and looked at, when we were fortunate enough to get sequences from test and trace, but there weren't enough cases. I reckon there was an increase in the discordance in the low viral load, so-called low viral load donors, but the numbers weren't quite big enough to make a big song and dance about it, so I reluctantly didn't pursue it properly.
I'm afraid that such dual studies as have been done, serial testing, lateral flow and PCR. In fact, the PCR signals positive before the lateral flow test. So yes, there are the residual positives at the extended end, but actually it's better up front. And the reason we don't. No,
okay, so the first day, I mean, this comes out in the volunteer work from Imperial. It's not quite, you have to go and disentangle the data quite carefully to look at it, but you certainly get I mean, just to be correct, they did daily PCRs and daily and saliva and sputum, I think, and lateral flow tests and culture. They did a lot. And lateral flow tests didn't do badly against culture in the early, but there is this question about that beginning window. And what we don't know in that early window, when the lateral flow test is negative and the pcRNA is going up, is we don't really know how infectious those individuals were in that 12-hour, 24-hour window when LFD misses it, because you're then making exactly what you're talking about, trying to infer things. And you ask, why did lateral flow test miss it if the PCR is not bad? What is it? Because, and then you think, well, is it possible that well, my sense is if you've been infectious, you ought to be teeming with stuff which the lateral flow test picks up. I'm finding it difficult to work out why saliva is negative and you're still infectious, for instance. But I don't, again, this is evidence free. This is all just make-believe.
And we couldn't afford the PCRs for people who are asymptomatic anyway.
No, but I mean, it is that day, but in intense transmission, that first day is a definite weakness, potential weakness relative, no doubt about that at all.
Okay, thanks very much. If you've got questions after this, I encourage you to talk to Tim at the break. And we can have to move on. So please thank Tim. All right. One good Tim deserves another. So can I ask Tim Russell to come up and talk now as well? How are you going to do this one?
Hello, everybody. It's an absolute pleasure to be here. Thank you very much for the invite. It's nice to be at an in-person event after so long. Thank you. I'm going to be talking